This is a second example of simplifying expressions. So if you look at this expression, we have terms that have an x squared, we have terms that have an x, we have terms that are on by themselves. These are our constant terms. So I'm going to go ahead and start circling the ones that are alike. So if I have an x squared term, I'm going to go and look for another term that has an x squared. So if I scan through, the other term that has an x squared is this one here. So these two will be combined. I will then look for the next one, which is 5x. Positive 5x, if I can find any other terms with an x, so it looks like I have a negative 8x here. And it looks like I have another negative x here. So I have to combine all of these together. Lastly, you see that I have constant terms. I have a positive 11 and a negative 15. I must combine those two. So I'm going to go ahead and rewrite them in order with their pairs or their matching or combining like terms. So I have negative 5x squared minus 2x squared. Then the next terms I have that are the same are the x terms. So I have plus 5x minus 8x minus x. And then lastly I have positive 11 and minus 15. So if I stick to these, the ones I need to combine, I notice that I have a negative 5 and a negative 2. If you remember, if they're all negative, I can add them together, right, and combine the negatives. So this is, I really have negative 5 here. I have 5 of them, and I have 2 more negatives. How many do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 negatives. Looking at these terms, however, I have a positive, and I have these two that are negative. If I combine these two that are negative, I get 9 negatives because there's that invisible one here. So there's 9 negatives because I have 8 of them plus 1 more. That is 9 negatives and a positive 5. So positive 5x minus 9x. Still bring this down. Combining those together, I have 9 negatives and 5 positives. I can match 5 of these with 5 negatives, leaving me with 4 negatives left over. And you could do that on the side. You could do negative 1x, negative 1x, negative 1x 9 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have 5 positives. Pairing 5 of those to make a 0. So here's this one pair, here's another pair, here's another pair, here's one more pair, and lastly 5 pairs. So 1, 2, 3, 4, 5. So notice how I was able to take 5 of these and pair them up with 5 negatives. So what I have left with is 4 negative x's. So I'm going to rewrite this. And then if I do the same thing here, I can pair up 11 positives with 11 negatives, and I would still have some negatives left over. I would have 4 negatives left over if you do this on the side. So this would give me negative 4. Lastly, if I look at this expression, I don't have any more x squared terms. No more x squared terms. I have only one more x, but I don't have any more x's alone by themselves because that's an x squared. That's an x with no squared on top. So I have to have the exact same term. So I don't have any more. And this one, negative 4, there are no constant terms anymore. So I can't combine these with anything else. So therefore that is my answer. So I'm going to go ahead and circle or box this